Okay, welcome back everyone. Today we're going to be looking at a lens/mirror lab that is commonly tested in Physics 30. Okay, so on Physics 30 tests, it's common to get a scenario about a lab or an experiment and you have to answer questions about it. And one common type of example is with an experiment with a light source or an object, which is going to be our candle, and that light passing through a lens and then getting focused onto a screen. Just before we get into the experiment, we've done diagrams related to this before, and I'll remind you of what that looks like. So I'm going to start with our principal axis, which goes through the center of the lens, and I'm going to draw our object here just as an upwards arrow, similar to the diagrams we've seen in class. Next I'm going to put the focal points on here, and there's two because this is a lens. Then to show where the object is going to get focused, or where the image is going to appear here, we're going to draw three rays. Ray 1 began parallel to the principal axis and then went through the focal point on the other side. And this shows that ray converging through the converging lens. Ray 2 is kind of opposite to this. We're going to start by going to this focal point and then is going to converge and exit the lens parallel to the principal axis. And at this point we can already see that this is going to be the converging point and our image is going to appear here. But you can always confirm it with the third ray, which goes through the center of the lens and does converge to the same spot as the other two rays. So now from this, I'll just draw the image. It's going to be inverted, and this is a bit hard to tell, probably slightly larger, but it's inverted image and it would be a real image. So questions like that for calculation we should be pretty used to, but now we're going to use this as an experiment example. So in an experiment, if you see a question like this, it's often moving this light source of this object and trying to see where the image is going to appear or where it's going to focus. So let's show that if we move the candle or object backwards here, I'm going to keep ray 1 the same because no matter where I put the arrow along the principal axis, this ray stays the same. The other rays are going to be changed though. The angle to the focal point has changed, so I need to redraw ray 2. And we can see that the intersection is closer to the lens and it looks like it is less far from the principal axis. We can confirm this with ray 3 as well. We have a different focal point here. So in an experiment, if we move the distance from the object to the lens, we should get a different result in the distance from the lens to the image. So I'd have to move my screen so I can capture the image now in this position. So really what's going on is we're changing the distance of the object, our DO, and we're measuring the distance to the image, our DI. These two variables are related in an equation we're used to seeing, which is 1 over F is equal to 1 over DO plus 1 over DI. So again, we are manipulating 1 over DO and measuring 1 over DI. In this experiment, it's common to get asked what the focal point is going to be, and we can determine that from graphing these two variables. So let's take a look at the equation and rearrange it so we can figure out the focal point. So here's that equation from before, and my responding variable was di. So to match this to y is equal to mx plus b, which is what we want to rearrange for to use a linear graph to find some information about the experiment, I want to rearrange for my y variable so I can match it to y is equal to mx plus b. So basically I want to get this by itself, so I'm going to move 1 over do to the other side. Okay, let's rewrite that out. I have 1 minus 1 over do now, because I moved it to the other side by subtracting, is equal to 1 over di. This is looking pretty good so far, but since I want y is equal to mx plus b, I find it a bit easier to put your y variable on the left, so I'm just going to switch this around to this format up here. It's the same equation, just flipped around. 1 over di is negative 1 over do plus 1 over f. And this is very close to y is equal to mx plus b, but I think the challenge is saying, well, what's my slope going to be? What's the m value? All we're going to kind of factor out here is the negative or the negative 1. So I'm just going to show it here as 1 over di, 1 over f still in the same position there, and now negative 1 over do is just negative 1 over do. And this lines up really well with y is equal to mx plus b. You can see the y, or the responding variable, is going to be 1 over di. The x, or manipulated variable, is 1 over do. And it tells us that our slope should be negative 1. Our line should be going downwards, and it should be a negative 1 value for the slope. And then to determine f, which I mentioned at the start, that will be related to my y-intercept. My y-intercept b is 1 over f. So taking a look at that on a graph, I'll put those formulas back up here and begin with my y-axis should have 1 over di. This may also be stated as the reciprocal of di, or distance to the image, which means 1 over di. The reciprocal of the distance to the object is going to go on my x, and the units may look a little confusing. It's 1 over meters, or meters to the negative 1 is another way to represent that. And then once we put our points on the graph, it won't be perfectly straight, but we'll get a pretty linear relationship that we can draw a line of best fit through to show this data. Now right off the start, we can see this is a negative slope, which we are expecting, because once again, our slope should be equal to negative 1. It could be a little bit larger or smaller, which could give you some information on where there may have been errors, but it should be pretty close to negative 1. To determine the focal point, again, that is the y-intercept that's going to give us information. So we're going to look at where our line of best fit intersects the y-axis. And just for an example, let's say that number was 5.4. If that's the y-intercept, b, that is equal to 1 over f. So we can write this as 5.4 is equal to 1 over f. To solve for f, just flip f and 5.4 out, and we would get an answer of the focal point to be 0.19 meters. Okay, so I hope that helps you to understand how to complete this question in case you see it on assignment or a test. Thank you so much for watching this video, and I'll see you in the next lesson.